In this example, we have a quadratic function whose equation is given in standard form. And we're asked to graph this function. So the first step is we can find and graph the axis of symmetry. And the formula, that is one of the few formulas that are really important to memorize, is x equals negative b over 2a. So we're going to do the opposite of b over 2 times a. And we're going to work that out to be x equals 1/2. That is a vertical line passing through the x-axis at 1/2. And that is my axis of symmetry of this parabola. Once I found my axis of symmetry, I know my vertex lies somewhere on that line. So what we're going to do is substitute 1/2 in place of x in the standard form equation, and we're going to solve for y. So the y value is -5/2, so I know my vertex has coordinates 1/2, -5/2, so I'm going to plot that. So now I have my vertex. And this particular curve definitely opens down because the leading coefficient is negative. What we could do is find the y-intercept, graph it, and graph its reflection. The y-intercept is the constant term. It's the c. So I know my y-intercept is -3. I can plot that. And I'm going to plot its reflection as well across the axis of symmetry. Okay, the next step, we're going to find and graph another point that lies on this parabola and its reflection. And so I'm looking at an x value of 2. And if I substitute 2 in place of x in my original equation, I can get the y value that corresponds to x equals 2. So I can see that the curve goes through 2, -7, so I'll plot that. And then I'll plot the point that matches it on the other side of the axis of symmetry. And the last step is we're just going to graph the curve. We're going to connect these dots with a smooth curve. And this is our graph of our quadratic function y equals -2x² plus 2x minus 3.